Hello there, welcome back to another video. Thanks so much for tuning in. Today we have a 4L80E. It came out of a wrecking yard, a 97 or 98 model, I'm not exactly sure which. It was actually came into my possession as part of a trade deal for a 4L60E rebuild where the customer was originally going to swap this transmission into his Tahoe as is, but he decided to have me rebuild his 4L60E instead. So we're going to use this as a core to build up a level 2 4L80 for a customer who's going to be retroing it back into a classic K20 truck. So let's move a little bit closer to the bench and we'll get started. So you know this is a 97 or 98 unit by the lack of a bowl hole location here at the 12 o'clock position on the bell housing, in combination with the fact that there is a center lube return oil position here in the middle of the case. So all your 91 to 96 units, they have the core line fitting somewhere around in this location. It's a traditional rear lube design, if you will, and 97 and up. The 4L80s, they changed that to have the gear set in the rear lubed first directly with cooled return oil from the transmission coolers. So we got a bolt-on yoke. This takes 3/4. Alright, this transmission is actually going into a 4x4, K20 4x4, and so we're actually going to delete the two-wheel drive application, extension housing, output shaft, and whatnot, put a lube plug in place of the orifice lube seal that allows oil to go to the extension housing bushing here, and that will allow you to convert a two-wheel drive 4L80 to one that can be used in a 4x4 application. Alright, 15mm extension housing. This came from a local wrecking yard who has a pretty good reputation as far as just supplying parts in general. And to be clear, whatever it is we find in here, you can't really hold the wrecking yard accountable because all they can really do if the customer installs it and it doesn't work is to replace it under their warranty. And I believe they offer either a 90-day or a 6-month. Depending on whatever it is you're buying as far as powertrain components like transmissions and engines. So a shaft spins nice and free. We hear the low roller clutch. That tells me that it's healthy, although if the roller clutch isn't making any noise, that does not mean that it's impaired in some way. Some of them don't, even right out of the box, but most do. You'll hear that screeching with most one-way roller clutch assemblies. Alright, this is 15mm, and then 13mm for your manual lever position sensor bolt. This thing's pretty nasty, like most of them. Alright, so this has a 2-connector manual lever position sensor. I want to say in 2004 and up they went to the single connector version. And I believe all of the aftermarket controllers that are compatible with 4L80E transmissions, they can use either or, to my knowledge. That thing was stuck on there. It did not want to come off. Quite a lot of dirt and grime. Alright, your 2 speed sensors, they're identical, front and rear. So if you're having issues with drivability symptoms that are commonly associated with speed sensors, like either harsh upshifting or downshifting or no upshift out of first gear. You can swap the two, one for the other, and see if the condition changes or if it follows the speed sensor. And if so, then you figured it out. You've determined that the one sensor is no good. You always replace this kind of stuff. I mean, I harp on this in all my videos, but just in case this is the first video of mine you're watching, never reuse electrical components, especially the wiring harnesses. These are notorious for leaking through the case connector. And when that happens, you may experience a limp mode condition because the fluid is shorting out the electrical signal that's trying to pass between the wiring harness and connector from the PCM to the transmission harness and all the associated solenoids and whatnot. Alright, so I like to use an impact driver on the shift cable bracket bolts because they can strip out, and we don't know if they were over torqued or what kind of bond they have with the threads in the case or on the case. So torque's 40. And for these center loop design cases, you also have to remove your rear cooler line fitting. If you fail to do that, then you will not be able to get the gear train out of the case because this thing goes into the center support, as you can see here, and there is an O-ring at the base of the fitting. So here's that lubrication orifice seal that I was referring to earlier. All right. Just want to do a quick hasty end play check. So with 4L80Es, TH400s, and many other transmissions that have input shafts that are not pressed into a drum or some other housing, oftentimes are secured with a snap ring. And so that snap ring, in the case of the 4L80Es, secures the input shaft to the Overdrive planetary carrier. And as a result, you're always going to have a little bit of play between the input shaft, snap ring, the carrier, and the groove that has to be netted out when you calculate and measure your front end play. So here, I can move it inboard all the way, you'll move it out, you'll come to a stop, that's the snap ring, and then you want to come further forward, and that's the end play. So let's do it again. Push in, pull out, right here, and then that second little bump you heard was the net end play. Alright, I believe most of the bolts are actually in the pan, but I could be wrong about that. Oh, I got 8mm, these are 10mm, I don't know why I grabbed the 8. 10mm bolts. And this fluid is very dark, stinks real bad. So again, sold as a working unit. I have my doubts. There's the rest of the bolts. Okay, pretty nasty. There's our magnet. And then we have a standard rubber gasket bolt. Okay, never use these. They like to leak, they're no good. They don't seal very well in the long run. Yeah, that fluid looks nasty. I'm probably gonna just replace this pan as well. I mean, it's got a drain plug in it, but either that or I'm gonna have to media blast it. It's no way that all that crud is just gonna come off in normal, you know, traditional type washing methods. Very nasty. Okay, so here's your wiring harness. This appears to be the original. You know, doesn't show any signs of ever being replaced. So again, always replace the electronic components. Also make note of your harness's organization keepers. So you have one here and one here. Don't want to come out. Alright, we'll have to mess with that later. So all of our bolts are going to be either 8mm, 10mm, 8mm bolts here, 10mm everywhere else on the valve body. And then this bolt right here underneath your lube tube from the valve body going into the rear of the case for the rear case bushing. This has to be torqued down first on reinstallation before you install your tube. Otherwise it'll be very difficult to get to. Alright, 8mm now for our pressure switch manifold assembly. And I actually should have removed this pipe first before I took off those other 8 bolts for the manifold. Let's see if I can get it out without any issues. And there we go. I want to avoid bending this if at all possible. I'm going to break it. One more 10mm bolt now, and then valve body should just come off, but it may be stuck to the separator plate in case. Hopefully not, but I've seen that a few times when the transmission would suffer severe overheating events. Everything would be bonded to the case. Oh man, this thing absolutely stinks. Okay, you have a set of longer 8mm bolts here holding the accumulator stack to the valve body. We're not going to reuse the third and fourth accumulators, so we're not going to install this stack back onto the valve body. We're going to run a block off plate. Got one more here. So these bolts are all longer than the 8mm bolts for the pressure switch manifold assembly. So it'd be difficult to mix them up. Alright, so third and fourth accumulator, just note the orientation and arrangement of the springs. If you're going to reuse them, if you're going to keep the third and fourth accumulator circuit active in your build. Okay, you have a small E-clip here. Alright, and then to get this one out, you would put shop air right in this location here. I'll do that later. Alright, the spacer plate's not going to be reused either. I mean, there's nothing wrong with using the factory plate, to be clear, but I always do a transgo plate with these. See if this will cooperate. Looks like someone has been in here, at least in the valve body. This unit may have been rebuilt at some point in the past. But Transtech is obviously an aftermarket gasket, so we know that at least the valve body was serviced or worked on in some fashion at some point after this thing left the factory. Okay, so electronic pressure control solenoid, PWM solenoid, shift solenoids A and B, manual valve, and then for your valve body itself, I would recommend that you replace the factory torque converter clutch regulator valve with the Sonix valve that has a sealing ring on it that will seal off that bore. Otherwise, the factory valves are notorious for not holding sufficient vacuum. So this is interesting. We have a 96 casting code here on this valve body. So this is probably a 97 unit. It's interesting because this is the 97 and up valve body, layout, configuration, and design. The 91 through 96 valve bodies had a long feed pipe that went from roughly this area here to the back of the case to lube the rear case bushing. Same function as this little pipe, but otherwise different. And they're not interchangeable. So that's a kind of a neat find. I've never actually seen a 96 casting for a 97 and up valve body. Very interesting. All right, so let's go ahead and get this out of the way. There are special tools you could use if you wanted to preserve the harness to, collapse the little locking tabs so that you can reinstall it, but I would never ever recommend you do that for obvious reasons. So here's your braking band servo. This is your intermediate or manual second band and servo. Nothing really remarkable about it. TH400s, that design changed a couple of times, so you want to be aware. And then 01 and up, I believe, they went to a wider band here in the intermediate band position, so the servo piston changed again. The servo assembly, I should say. 10 millimeters here on your reverse cover for the low reverse servo. Okay, here's your gasket, here's your low reverse servo seal, and then you have your 1-2 accumulator piston here and its corresponding return spring. So one thing about these servo pistons, 96 and up, with the dome style design, is that they like to crack right in here. So my recommendation for anyone building one of these units 96 and up is to install Sonic's billet piston in the same position. You know, don't run the risk of having this crack on you, especially if you're doing either a high performance type deal or it's a heavy duty build, you know, a lot of towing and hauling, and where there's going to be a lot of work happening when in manual low. All right, I'm going to see if I can get that little E-clip out or off. So you just press down as hard as you can. Try to hold it with your hand so that you can remove the clip. And then it should just pop right out for you. Yeah, this is absolutely filthy. And there goes my 1-2 accumulator spring. Absolutely filthy. I'm hoping that we only have a soft part failure in here. You know, some clutch, maybe the low reverse page or something just got absolutely obliterated, but I'm hoping there's no hard part damage anywhere. All right, let's get moving. We have our check balls here. This is where they go. As you can see, this is the reverse check ball. It can be left out if you want a firmer shift or engagement into reverse. And then you can also leave the direct clutch check ball out as well. It's a number 8 ball if you want firmer engagement in direct. So up to you how you want to calibrate it. You know, if you're not sure, you've never done it before, just leave all the check balls in their proper positions and then just use the spacer plate feed orifices to make your adjustments to shift firmness based on converter stall, vehicle weight, and all that stuff. Okay, 13mm here, reverse hold down plate, excuse me, parking pole guide plate, not reverse hold down plate. I think I have a 4L60E. All right, then you have your spring. Leave this spring in place because that'll keep the parking pole out of the way so that you can, you know, pull out the entire gear set when the time comes. So I think that's Torx 30 for our overdrive feed bolt, and then 3/8 12-point socket for the center support feed bolt. So it's going to be to your intermediate clutch. Okay, new ones will come in the overhaul kit, but you can reuse the pre-existing bolt if it's in good shape. It's either Torx 30 or Torx 40 for this one. Yeah, it's Torx 40. Okay, new ones will come in the kit as well. New overdrive feed bolt. Alright, for your retainer, for the manual selector, just pop it out like that with a pry bar. You gotta be real careful. Don't try to bend it. You know, if you're using pliers, I don't know that I'd recommend doing that because there's just a tendency for your wrist and your hand to kind of bend the pin a little bit and break it. And if that happens, breaks off in the case, you will be there for a month of Sundays trying to get it out. Happened one time with me, and the machine shop literally took, they said it took like 3 hours to get it out. So, and I can't remember what I did to, you know, try and remove it, but whatever it was, it didn't work. Or I just screwed it up really bad. Alright, let's get the kick tension. So 13 millimeter on the pump to case bolts. Just want to make sure you can see what's going on. Okay, don't forget to remove your torque converter seal for your converter clutch circuit. A lot of times this seal will get hardened and you'll get converter clutch slipping codes, you know, P1870, P0894 and so forth. And with the 4L80s, a lot of times it is the torque converter, but sometimes it's that seal, and occasionally it's the torque converter clutch regulator valve as well. Alright, you just come in here, pry on it, and it'll break free. Alright, there we go. Is our bearing. This goes here on the forward drum. There you see pieces of clutch teeth. Direct drum. It's our intermediate band. More clutch teeth. Alright, then we got our intermediate clutch in there. That has to come out. We got our snap ring. Never reuse this snap ring. It's generally not a good idea. I mean, unless you're doing a purely stock rebuild. I mean, it's okay for that, but always replace it with a Chrysler 727 A518 618 Ford clutch selective snap ring. And I find myself using either the 75 thousandths version or the 88 thousandths thick version. Okay, so here's your cushion plate for intermediate, and then a look at the intermediate clutch pack. You have your bottom steel, friction, steel, friction, steel, friction, so 4 and 4. And then your pressure plate. Okay, 99 and up, I believe, is where they went to a thinner backing plate. I really shouldn't use the term pressure plate, it's not accurate, backing plate. And then now we have our center support, which also has a snap ring, which is bevel, it's a little beefier. So we gotta get that out of the case. Sorry, I'm just gonna have to get in here, you're not gonna be able to see it. I know that looked like amateur hour, but if you haven't seen this technique used before, to basically take a long flat blade screwdriver and cut a little notch in it to grab the snap ring, and that's how you start working it free of the lugs. Alright, so now we're in position to grab the entire rear gear set. So what I like to do is grab it by the output shaft, and then I'll also grab it by the center support stator and just kind of push it forward until I can get enough of it to where I can just grab up on everything. And then carefully take it out of the case. So at this point, all you have left in the case is going to be your anti-fretting snap ring or anti-fretting ring, real thin. And then your rear band. I'm going to look at the rear band. Looks okay. I mean, it's not burnt to a crisp. So the last thing that's going to be in this case is going to be the 3-tab steel selective washer in the back of it. So let's see. If not, it's going to be on the back of here, that is exactly where it is. Okay. All right, let's quickly go through the sub-assemblies, check them out, make sure, you know, we cover everything. So let me reposition the camera, get a little bit more optimal viewing angle for you. All right, I'm just going to start with the forward drum because it's in front of me. Why not? So here's the bushing. It's my recommendation that you install an Omega Machine wide forward drum bushing here. The other thing you really need to scrutinize is the inner diameter to see if it's wore out. Once we get a look at the clutch pack, it will give us an indication of the health of that inner diameter. A lot of times the input shaft sealing rings will cut deep grooves in that inner diameter, causing apply fluid to basically blow by, and you know, that's the end of the forward clutch. So backing plate looks okay. And the forward and direct clutch snap rings are not selective, they're exactly the same. So here's our hub. We will put a rollerized Sonex forward clutch hub in here. Looks like whomever built this, they put a brass thrust washer in both positions. I believe Sonex makes that washer, the one that replaces the plastic washer. So bonded piston. Here's our cushion plate. So flat steel, that's our bottom steel, and then our clutch. You see some delamination here occurring. Steel, clutch, this looks delaminated and burnt. So more of the same. Now this transmission would have had slipping occurring in drive if the individual had taken off aggressively. It's a piece of plastic something. So we have teeth and plastic material. Plastic. And get a look at the inside of the drum. The inner diameter, it's kind of hard to tell. To be honest with you, I actually can't tell either if it's smoked or not. But once I get it all cleaned up, you know, we'll know for sure. Either way, the process to remedy that is simply boring and sleeving the inner diameter there with a ductile iron sleeve, and that will fix the issue. All right, let's look at this Overdrive clutch. So I think this is where all of that nasty ass clutch material is coming from. Come on, get in there. These are all probably coned and warped. Yeah, absolutely charbroiled. That's where all the teeth were coming from that you saw a few minutes ago. we have everything welded. Not good. What a mess. Huh. Yeah. Look at that. Absolutely decimated. I mean, that whole assembly is no good. I'm not going to even bother reusing the return spring on it. Both coast clutch and overdrive clutch are shot, like completely shot. And we have absolutely no movement in the roller clutch. That's all welded up together. My customer, who had me rebuild his 4L60E, was wise not to use this thing. I mean, this is why you don't go looking in junkyards, salvage yards, and whatever for used transmissions. It's why I am a staunch advocate for not doing that. Not really sure what's keeping this on here like this. Unfortunately, we don't have all day to mess with this, but suffice to say that entire assembly smoked. And as far as why this happened, my guess is whoever built the unit may have, and I'm just, pure guesswork here, may have not installed the lip seals, fully onto the, they may have cut a lip seal or something. That's just a guess. Let me see if I can get this apart and confirm or deny that. Okay, gonna cut in here with a quick deep dive into the overdrive section components to better explain what happened here and why. So we have a smoked overdrive clutch and a smoked coast clutch. Anytime you have a clutch pack that looks like this, first thing you want to do is scrutinize sealing surfaces on lip seals, ply pistons, and things of that nature. So anywhere there is a circuit boundary. So we'll start with the overdrive clutch, and here we have our overdrive piston in this hand and our overdrive clutch housing in this hand. And what you want to do is just kind of go around and just kind of feel the lip seal and see if it's still supple or if it's starting to harden. And as I'm going around with this one here, it actually feels like it's starting to harden. This entire section here feels a little bit different than the rest of the circumference of the seal. So let's see if we can take it out. So we can handle it. And right up in here, and I know you can't feel it through the computer or video screen, but right in this area here, it's markedly harder than, say, over here where it's still nice and soft. And this by itself literally is enough to cause the kind of damage that we see here in front of us. So let's look at the clutch housing seal. Okay, this feels a little bit more even in terms of, like, hard versus supple. It doesn't have quite the change in feel as the piston seal does. It only takes one seal to be partially hardened to cause this sort of damage, because once fluid starts to leak, there's still enough pressure to partially apply the clutch. In other words, enough force to generate friction, which of course builds heat, but not enough to fully clamp it. And I don't know how long this may have been happening. Maybe it was literally in one drive cycle, a very short period of time, an extreme acute overheating event because of the hardening of that seal just got old enough to the point where that was it. But and as you can see, you got components welded to each other here, friction discs, steel plates, all welded. And I had to cut this thing off and get it free of the outside of the drum here to get it on the bench like this. So here's our coast clutch and our coast clutch apply piston. So you got an inboard sealing surface and an outboard sealing surface. And the outboard sealing surface to me feels like it's also a little bit hardened, especially right here. Right here it's pretty solid. And over here you can see it's still supple. Now right here it's pretty solid. Over here it's supple. So again, same kind of differentiation. Look what happened to the lugs on this drum. This is going to be your overdrive clutch hub here, this portion of the drum. And this drum is shot. All the lugs have been completely worn off, basically almost sheared off. The input shaft looks like it actually survived this. It's got some, what I would call witness marking from the bushings in the pump on these journals, but nothing that would lead me to believe that the shaft is compromised. I mean, a little bit of sandpaper, this comes right off. So if you're really concerned and you have a failure like this, you can magnaflux the shaft to see if there's any micro cracks that would otherwise escape detection. I'm probably not going to use this shaft, given that it was subjected to a tremendous amount of heat, but superficially it looks okay. I mean, I'll magnaflux it maybe at a later date, but the splines look good, the journal looks good, the body looks okay. And then we have our planetary carrier assembly for overdrive. So again, some witness marks here on this cover plate, or this this portion of the planet, but the splines look good. And believe it or not, the planets are also in good shape, or I should say the pinion gears. The capture bearing is spinning nice and free, it's not making any noise. And then you see here in the interrace, get that wiped off, interrace, you do have some witness marks where the sprag was thrusting against the race, and it looks like scoring, but I cannot feel anything here with my finger. That said, I don't trust this planet either. Given the amount of heat that this thing's subjected to, we're going to just swap the planet. We're going to replace the overdrive piston and clutch housing, replace the drum, swap the input shaft, and then also I'm going to swap the spring retainer for one that's not kind of bent up. It'll need coast clutch and overdrive clutch backing plate. The return spring assembly for overdrive actually looks okay in all respects. I mean, it and the snap ring can probably be reused. They'll just have to be a little bit more scrutinized. So I use that Milwaukee cutoff tool to make the incision here on this steel clutch welded pair there, so that I can get it free of that drum. So anyway, I just wanted to show you guys that, so that you got to see everything versus me just pushing it to the side. So we'll go ahead and resume with the rest of the teardown now. It's too far gone. Let's look at the direct clutch and then we'll look at the pump and then be done. Or gear train too. We'll look at the gear train and then we'll be done. All right. So direct clutch. This is our cushion plate. Should be 5 and 5 in here, 5 flat steels, 5 frictions, so some more delamination. I'll be honest, from what I'm seeing, I mean, if somebody did do this, it's probably a flat rate job of some sort. You know, somebody did go through it. And the only reason I suspect that is the presence of the bronze thrust washer in this position when there's normally a plastic one. Normally. I mean, maybe the factory did install bronze washer there. So here's sprag rotation, intermediate clutch. You should have a 34 element heavy duty sprag in these later units. Always replace your one-way assemblies in all transmissions that you build. Never reuse them. Especially not in absolute disasters like this unit. Alright, so you want to check your inner race and the inner diameter of your outer race. You want to make sure there's no scoring, no unusual or excessive wear. And then go over the inner diameter here on the outer race with like 320 grit sandpaper a whole bunch of times, and that will allow you to freshen up the surface for the new sprag element when you install it. Okay, check your inner diameter here for where the center support ceiling rings go. Okay, if you're gonna dual feed the transmission internally, when I see dual feed, I'd say quote unquote dual feed. It's not really a true dual feed, but what you're doing is increasing the clutch apply volume in third gear. You leave the second from the top ceiling ring off. Okay, you leave the center seal off of this drum, and then you plug the high reverse feed passage in the case itself, which is going to be right here. Okay, and then as far as calibration, I have a couple videos that walk you through some different options based on whatever scenario you're running. But that should get you where you need to be in terms of beefing up that part of the transmission, especially for performance type use. Okay, unfortunately, I'm probably not going to be able to tell if this gasket is original or aftermarket, given its condition. It's melted basically to the pump cover here. Okay, this selective washer is what you use to adjust your front end play to get it dialed into where it needs to be. Most commonly I see 90 thousandths, 90 thousandths washer there, but I've had to use all different sizes over the years just to get the front end play correct. Alright, so these pump cover stator support assemblies for 97 and up, from 97 to 03 and 04 and up, there's actually 2 different versions of them. So I'll flash a chart on screen so you're aware of that. Transgo has the details on their website. You can check it out. Our 480E subsection. So feel in here for any kind of ceiling ring groove wear. Okay, check your journals. Okay, this journal shows a little bit of signs of heat, but nothing crazy. Okay, even check here where the selective spacer sits. And then of course you're going to check your working surface. Most of the time you need to resurface the pump, both the stator and the body. There's usually a lot of scoring, and it's not flat anymore. So this is no different. It has to be machined. And then you want to vacuum test your pressure regulator valve, your boost circuit. You want to replace the boost valve with a 480E LB1 O-ring boost valve. And then the pressure regulator valve, you can either use the stock valve if it's good to go in terms of vacuum signal. You want to see a bare minimum of 15 inches. I prefer 18 and up for performance 480s, or run the Sonic's lube regulated pressure regulator valve. It's gently oversized. It'll improve the vacuum signal and also provide you line to lube, so you will not drill a little 55 thousandths line to lube orifice here in this part of the pump cover. Otherwise you would drill in this direction, starting here and out through here. It's part of my lube mods video. You can check it out if you want all the different lube mods that you want to do on these 4L80s. Okay, let's see this body. Most of the time I replace the bodies. Yeah, they just need it. Alright, let me see if we can do a preliminary inspection. As you can see, we have a lot of wear in the crescent. This is no good. This disqualifies this body from being reused as is. And then you have a lot of scoring on the base here of the pocket. So this body is no good. When I price out a core, I price it out with replacing the pump and one other hard part. So it's going to be that overdrive section. That's, like I said, it's already figured into the cost. So dots face up on the drive gear. So driven gear and pump bodies, brand new ones are available in the aftermarket from Transtar. That's what I use. They're actually very good. I've never had one not meet pump clearance specs. So that's if you're looking for something to use or purchase in terms of replacement pumps, at least the body, then that's a good move for you. Alright, a little sloppy here coming out. So here is our sun gear, and then our sun gear shaft. These bushings, just like all the bushings in this transmission, get replaced. And then when you go back with it, make sure that your lube hole here and the lube hole here line up. Okay, they just need to line up. Alright. Alright. So this is going to be a 4-tab washer. It goes on the front of your output carrier. Okay, there's 4 tabs and 4 seating locations for it. I want to say in 01 and up they went to a 2-tab thrust washer there, and they eliminated 2 of the tabs. Okay, here's our sun gear to center support thrust bearing. That goes here. And then the top half or top race is right here. Alright, center support. You got a bushing here you replace. These bushings are different, 91 through 96 and 97 and up. You want to check your inner race for your low roller clutch assembly, and then check your journal here for bushing. This goes to the front planets bushing. Okay, here's your thrust washer here, and that goes here. I'm going to take this apart. I actually have to move some of this stuff out of the way so I can get access to the hole in the bench, because I want to see if somebody did rebuild this, if they erroneously put that 41,000 shim that's only present in 99 and up units in that location behind the sun gear to ring gear thrust bearing. So let me change battery out and then we'll continue. Alright, fresh battery in. So let's continue with the gear train. So here is our low roller one-way clutch. Always gets replaced. Then check the planet band surface for your low reverse band, and then check the planets for side play. And then you want to also check your cam lobes. Make sure they're not unusually worn. It's pretty rare, but I always look at them anyway. And then check your vertical play as well for all of your pinion gears. So if you see side play, that tells you that the little needle bearings between the gear and the pinion shaft are wore out, and the plane will have to be either overhauled or simply replaced with a good used one. And then R&R the bushing. Okay, center support. Should be able to get this snap ring out of here just by pressing down on it. Okay, for all high performance applications, I recommend you run a heavy duty spring retainer, and this is why. You can see this one here, the factory one, is bent. It's often bent. You know, very common to see that. And then you have your piston. This piston changed in '96, I believe. 1995 was the last year, the late TH400 4L80E piston, but don't 100% quote me on that. I'll annotate the video so that you have accurate information. And if it's different from what I'm telling you verbally, go by what I write in the annotations, not what I'm telling you now. Alright, check the sealing surface for wear and scoring. This superficially looks okay. You have your interlock style sealing rings. These were standard from the factory starting, I believe, in '97. '96 and back, they used, what did they use? I think they used either scarf cut sealing rings or solid one-piece sealing rings. I think it's solid one-piece sealing rings. Alright. So here's our 4-tab Babbitt washer. If you're going to rollerize the rear of the case, you're going to eliminate this Babbitt washer along with the steel 3-tab selective washer, and you're going to replace it with a TH350 pump bearing and shims, and that will rollerize the rear output thrust for you. Okay, and you're going to install the bearing, would be technically upside down in the case, so that the rotating surface faces away from the bushing. So if you're going to run a Sonex one-piece rear case bushing, install it from the rear so that there is enough material there on that bushing to locate your bearing and keep it in place. I'll try and get underneath this thing. Okay, here's our output shaft. So we have another Torrington bearing assembly in here. This bushing will need to be replaced. Okay, there's two different types of two-wheel drive output shafts that I'm aware of for 4L80Es. This one, which is an O-ring style or design, and then you have the slip yokes compatible output shaft that does not take an O-ring, and the splines, you know, extend much longer up the shaft. Okay, this will receive all new bearings. Normally you could reuse them, but when they're this, you know, the transmission comes in all burnt like this, I tend to replace them. Alright, so here we have our bearing for sun gear to ring gear, and you'll notice there is no 41,000 spacer here, and there should not be. 97 to 98, the entire gear set is considered a service pack, meaning you can prospectively install the entire gear set from the center support to the output shaft and any 99 and up. However, and you can do the same for the 99 and up gear set service pack back to 97 or 98. However, you cannot retro either gear set back to anything 91 through 96. Now, that's as a service pack. You can, all right, I repeat, you can swap planetary carrier assemblies by themselves between early and late 4L80Es up to 1998. So in 1999, what they did is they changed the design of the housing to allow for taller pinion gears. So the 99 and up planetary carriers, the sun gear shafts, the center supports, the inclusion of a 41,000 shim so that the sun gear remains centered between the two planetary gear sets, so it's meshed correctly. All of that figures into your 99 and ups versus your 98 and 97, and conversely your 91 through 96. But the planetaries you can retro, and you can even retro all the way back to TH400s, but just know that these planets, the rear ones, they're a little bit different here between where you have this reluctor ring pressed on compared to TH400 planets. So you can't prospectively install a TH400 planet if you have designs on converting from four-wheel drive to two-wheel drive in the rear. If you need to install a reluctor ring, it won't work. They're just, you know, differently shaped. All right. Is there anything else we need to discuss with this thing? As far as what happened and why this occurred, could be a myriad of reasons, but I mean, I can't get this apart. I mean, I will eventually, but I'm probably going to have to, you know, press it such that I can get this return spring far down enough so that it'll free up the snap ring using some tool. But as far as what happened here, my guess is possibly too much towing in overdrive, or you know, a lot of high RPMs or racing. I mean, you know, this looks like it came out of a truck, so racing is probably not, you know, as likely. Lack of maintenance, fluid never changed. This fluid, it kind of looks original to me. Just, you know, my guess. But this thing probably has, you know, well over 150,000 miles on it, maybe 200,000. And that's, you know, also going to factor in to the condition. But seeing this stuff all welded together, I mean, that's not normal. Even in units with that kind of mileage, you normally don't see that. So something took place, one thing led to another, and the overdrive clutch was absolutely smoked, as was the coast clutch. And I think it's towing because, you know, I mean, unless the overdrive clutch burnt up and got so hot that it also melted the coast clutch, I think both of them burned, and, you know, just simply wear, tear, use and abuse, and lack of fluid changes all conspired to doom this transmission. So B&R would have had to make good on it under warranty. You know, they're the wrecking yard, otherwise they would have absolutely no means of knowing that this thing was in the shape that it was in, other than maybe the fluid. And then, you know, if I'm the yard manager, I'm probably saying, okay, I'll sell this, but as a core, not as a drivable unit, because, you know, given the condition of the fluid, and they would have had to have seen it because they had the pan off, I would have assessed a very high likelihood of it not working out for whomever bought it and tried to install it. So anyway, that's the video. As always, guys, thank you so much for watching. If you have any questions, comments, go ahead and leave below. If there's anything else I didn't cover, or, you know, you have any questions, just, you know, put them down there in the comments. Or if you have video suggestions for 4L80s, I'm always doing them. Go ahead and put those as well, and I will prioritize the video as soon as I can. All right, take care, enjoy the rest of your day or evening, and hope to see you on the next video. Thanks again.